Swayam Prabha. Digital India. Educated India.
Today I am going to talk about how you can make composite laminates with the help of composite material. There are several techniques that are there. So I am going to talk about first about the hand layup technique. I am going to first talk about the hand layup technique, and then I will talk about spray layup technique, which is slightly faster, pultrusion process, pre-preg making, resin transfer molding, and finally pressure bag and vacuum bag techniques. So the earliest method of making composite is through the hand layup technique, and in this technique, as the name suggests, that you have to apply the gel coat to the open mold to avoid first the sticking of polymer to the surface. So let us say this is the mold surface, for example. This is the mold surface, and on the mold surface you first apply the gel coat, and then you make the reinforcement, or sometimes we call the reinforcement to be something like the fiber based, the prefab structure. So that reinforcement you then place it to the mold. So that is the yellow part, that orange color part that you have here, and then over that you pour the resin. So that is the resin, you are just directly feeding the resin, and the base resin is often mixed with a catalyst hardener, and so that it gets hardened very fast. So this is the dry reinforcement, okay, and once you are applying the dry reinforcement, over that you are placing the resin. And this layup you can do it layer by layer by layer, which means you first apply one gel coat, apply one dry reinforcement, put the resin, then again the second layer, like that you can build it up. So that is the process of the hand layup technique, and after this whole thing is done, then you have to keep it for curing. For epoxy based system, the normal curing time at room temperature is about 24 to 48 hours, and naturally, as the name itself suggests, that the epoxy based matrix you are using, and this is mainly suitable for thermosetting polymer based composites, where you just, after you make the whole thing, you just put it on the oven to get it cured. So that way it goes very well, and that is the usual hand layup process. You can do it layer by layer. For example, here I can show you that this is one composite that we have developed in this manner. As you can see here, that there are several such layers. Okay, this is a flat plate, so there are long layers as well as cross layers, several such layers over which we have applied resins, and this still the additional resins, you can see the extra resins are there at the ends of it. Okay, so and once you do that, then once it gets hardened, then you cut it into a piece like this type of a piece itself. This is a glass fiber reinforced plastic. You get this through the hand layup process. So what is the advantage and disadvantage of this process? Advantage is that it is low cost tool. You can do it like in a very small setup. It is very versatile. You can make your own mold shape and you can do this. But the disadvantage, first of all, is that this is a manual process. So hence it is time consuming, and when you are doing this, applying the resin, there is these chances of air bubbles getting entrapped. So easy formation of air bubbles and disorientation of fiber. If you look at once again this whole thing very carefully, you can see this disorientation of fiber, right? You can see that the fibers are not very straight. When you are pouring the resin, it is getting displaced. So you do not get a homogeneous distribution of the fiber. So that is the another problem in the hand layup technique. And also you cannot control the thickness very much. So there is a lot of thickness variation that can happen into the system. So that is our hand layup technique. Slightly better technique is the spray layup technique. So this is an extension of the hand layup method, and in this case, instead of using the resin, pouring the resin, what you basically do is that you take a resin supply through a chamber, pipeline, and there is a catalyst that is coming. So these two are getting mixed here, and then the resin is coming out. Not only that, many a times what we do is that the fibers also, like using a chopper gun, many a times we also spread the fibers through the same process, and sometimes you use the reinforcements directly as has been shown here. And this spray pressurized resin can actually get more uniformly coated, okay, and it is in the form of chopped fiber. You can do it, and the matrix material and reinforcement, they get simultaneously sprayed or separately, either of them, and you then use a roller in terms of making this very kind of a uniform thickness. So there are two types of reinforcements you can give. Either is like the hand layup technique, you use the reinforcements like prefabs beforehand, as has been shown here, or the other cases what you do is that you take the fiber from the roving, as has been shown here, and this fiber you just chop it here. There is a chopper gun, and you spray this fiber along with the resin, so that the fiber in this case is not a continuous reinforcement, but it becomes a chopped reinforcement, randomly aligned, and sometimes you can even align it also towards the flow direction. So that is your spray layup technique. The advantage is this is a continuous process. It is much better than the manual process, faster. Any materials can be used as the mold in this case, and error can be corrected very easily by the respraying. Disadvantage is it is still slow, and there can be inconsistencies. There is no control over the fiber orientation, because you are just chopping the fiber and spreading. Only one side finished, and it is environmental unfriendly. Possibly that is one of the most important reasons why this is not used much, because you see you are chopping the fibers. That is dangerous also, because many of these fibers, as you chop them, and if you inhale it, ingestion, it will be very, very dangerous for the health. So hence this procedure is not very environment friendly. Now there is one way of making actually continuous fully automated composite laminate, and that is called pultrusion process, which is a mixing of pulling plus extrusion. So what you do in this process, that you take the fiber from the fiber rovings, and as you can see that they are getting a resin bath here. So this is resin impregnation tank. So as the fibers are pulled through the tank, they are getting a resin bath. Then there is a preforming die where actually these additional resins are taking out. Then it is going to the curing die where it is getting heated, and in the pullers just outside you are pulling this whole thing, and also you are maintaining the thickness to that process, and there is usually something like a chopper here. So beyond a certain size, you just simply chop it at this location, so that you start to get plates out of it. So that's what is the pultrusion process. It is just like, if you think of it, that this part is just like your pizza making process. Okay, so very similar, that a continuous belt actually takes this fiber with the resin and gets it cured, and then pull it through the puller and then chop it. So this is an automated process for continuous manufacturing of constant cross section profile. And the profiles are, now that in this case the fibers are perfectly aligned. So suppose if this is my plate, then all the fibers are perfectly aligned. That's how you are impregnating them and you are pulling them. So they have a high strength in the length direction. So that's the good part. The principal reinforcements are glass fiber, carbon fiber and aramid fiber, and you can get from anywhere from 40 to 70%. 70% is quite a high number of volume fraction in this. And the matrix material, that's very interesting, that you need not only work on epoxy resin type of thermosets, but you can work on polyesters, so thermoplastics, vinyl esters, etc. So that is what is the pultrusion process. So what are the advantages and disadvantages? Advantage is that this is an automated process, as you have seen. It's a high speed process and you can make versatile cross sectional shapes and continuous reinforcements. Disadvantage is that the die can be easily messed up, okay, because you are putting it in the die bath and the die can get hardened, for example, and once the resin is pulling, the die can get contaminated. The dies are expensive and mainly thermoset matrix is used in this case. So I think the greatest limitation is that the shape and size are generally of a very defined shape. You cannot do too much of a complex shape. Suppose I have to make something like we will see it today, something like a wheel rim. You won't be able to do it. You will be able to get something like this type of a rectangle, and then you can cut a wheel shape or a circular shape out of it. So you cannot make, there is no way you can make directly this type of a system. There is another way out which is coming up in a good way. It's called the pre-preg process. So here the fiber reinforcements are impregnated with a specific amount of epoxy resin system in a separate step before the layup. So basically you can buy from the market these pre-pregs. Now in the so-called pre-pregging step, fibers are actually weighted uniformly and a pre-preg of high quality is formed. And once you are forming this, so you can see here fiber reinforcements, epoxy resin is coming up, you are pre-pregging, okay, and then you are cutting and layup is taking place, then you are pre-forming the whole thing, okay, and then transfer this pre-form into the mold, then you cure it, and finally you opening and demolding it. So basically this pre-forming up to that stage, you are actually using these already impregnated laminates. The advantage of pre-preg system is that the orientation of the fibers can be suitably changed, okay. So in one layer you can have like multiple layers. If I look at the cross section, I can have multiple layers of multiple direction of ply. So that means something like 0 degree, 45 degree, 90 degree, I can vary it. So orientation of fibers can be changed. It is consistent and it has a high productivity. The disadvantage of pre-preg is that the continuous process needs more actually demand, and it has a limited shelf life. That shelf life is limited because the resin can get set anytime, and then there are possibilities of delamination in the system. So basically we have thus seen the 3 or 4 very important techniques, okay. So resin transfer molding is another process that we use, okay, and in this case what we do is that we first take the fibers, okay, the fabric form, you lay it up so that you actually make it of various angles, like this is 0 degree, then this is 90 degree, again a 90 degree, etc. And then once you make all these 0 degree, 90 degree layups, then you put it into the preform tool, and once the preform tool you put it, you get it into the shape you like, okay, and then you stabilize the preform often with the help of temperature and pressure, and then you take this preform in the transfer it into the mold, where you basically inject the resin into the system. So the preform is injected with the resin, and then you cure it, and after curing you get the complete product that comes out of the system. So in terms of time, this takes about 10 seconds for the preform to mold, 20 to 40 seconds for mold closing and resin injection. Curing is about 45 to 120, and opening and demolding takes about 10 seconds. So the whole thing takes close to 3 minutes or so, 3 to 5 or 6 minutes. So that is the fastest procedure, essentially the resin transfer molding. Now there are two additional things that one can do with the resin transfer molding. One is pressure bag molding, another is the vacuum bag molding. In order to improve the fiber volume fraction, suck out the additional resin and make it more compact, you can either use air pressure bagging. So here once you have the mold, you apply the air pressure. Okay, so you have a pressure plate here which keeps this whole system into a place. Apply the air pressure, and then there is a resin trap from which the additional resins actually come out of the system. So inside, so this is your mold, this is the mold system, then you have the glass reinforced plastic layer, and then you have the pressure bag. So through the pressure bag you apply the air pressure. So that is the pressure bag molding. Even better is that instead of applying air pressure from outside, the pressure bag itself you can make it as a vacuum bag. So and then you use a vacuum pump so that you suck out that vacuum, suck out the air, make it vacuum fully, and then the outside air itself is going to pressurize it very uniformly. You don't have to pump air into it, and then you get a much better finish, which is also known as the vacuum bag molding. Now I am going to explain you this entire process of making this carbon fiber laminated composite, or for that matter any such laminated composite, through a hand layup technique and with the help of a video. And this credit of this video goes to this Remi team of Finland. So we have taken their video to explain you this whole problem. So let us just look into it, how you will be doing this whole thing. So as you can actually see in this particular case, that first of all you are cutting the carbon fiber and of a particular shape that you want to do. In this case they want to make a circular shape, but instead of making the whole circular shape, they are cutting it into various pieces, like 6 to 8 pieces. Okay, and then that also can be developed in terms of layers. So first you clean up this whole space, the so-called mold space, and then on that mold, so you actually apply some release agent so that it comes out very well, and then you start to apply the glue and the carbon fiber. As you can see that the carbon fiber here is getting applied, and this is like it can be of two types. One is that you add only fiber, or you add carbon fibers like in the pre-preg form. That means the carbon fiber is already having glues in it. Now once the required number of carbon fibers you have applied, then what they are doing is that they are applying this white thing, which is the release films, so that it comes out very easily. And also the breather you have to apply so that it gets cured very easily. And then you have to apply the vacuum bagging. So basically they put the entire thing into the vacuum bagging system. Just now we have discussed about the vacuum bagging, and you can see that how they have applied the vacuum bagging system. And after they have sealed the whole thing, now what they have to do is that they have to make this whole thing in such a manner that they have to take these additional pipe lines so that the extra resins etc. can go out. So now they have kept the resin, and now they are actually going to take the whole set and they are going to apply these vacuum these things into it. So they are as you can see that they are infusing the part with the epoxy resin, and you can see that it is gradually that vacuum space is getting actually filled up. The resin is impregnating the carbon fiber and they are getting the entire wheel type of a cover system, and it's pretty fast actually. So this whole thing has been like in about half an hour to maximum 40 minutes you can actually make it, provided your mold and other things are ready. So thus they have done it. After this they have to put it for curing. So they are just opening up the vacuum bag and taking the whole system out, the carbon fiber reinforced system, and then you need to cure it. Now in some cases they put it in autoclave where both the pressure and temperature is applied, and in some cases they only apply temperature and cure it. And here you can see that the entire product is there. All the thing additional that you can do is to chop these extra fibers. So that is the way you can actually make a carbon fiber reinforced system. So this is where we are going to complete this composite manufacturing, and in the next lecture we will learn about smart materials overview and types and their need.